So in this video we're going to be looking at functions and linear equations. First of all, we need to understand the concept of the coordinate plane. So what is a coordinate plane? Basically, a coordinate plane is a two-dimensional system used to locate points in space, and it consists of two perpendicular lines called the axis. What I'm talking about here is that you have something like this. These are the two perpendicular lines. Perpendicular in the sense that they are inclined to each other at 90 degrees. So we have the y-axis and we have the x-axis. Okay, so the horizontal axis is often referred to as the x-axis, which we have here, and the vertical axis is known as the y-axis. Of course, we have positive y here, and here we have negative y. This is positive x. Here we have negative x. Now the point where the axes intersect is called the origin. So the y-axis, this straight line and this straight line, they intersect at this point, and this point is known as the origin, and this origin is denoted by 0, 0, meaning that 0 corresponds to x and the other 0 corresponds to y, and is denoted by the coordinate 0, 0, that is x and y coordinate. All right, so that is that about the coordinate plane. So we want to now look at how to locate points in the coordinate plane using the ordered pair concept. So what is an ordered pair basically? Now an ordered pair gives the coordinate and location of a point. Let me underline the keyword. It gives the coordinate and location of a point. So we are going to be looking at the ordered pair of a2, 1, b minus 2, 2, and this, and it can be shown in the quadrant 1, 2, 3, 4 as shown. So I'm going to be drawing this using the Cartesian coordinate as has been explained previously. So look at this now. Let's say we have the coordinate system like this, just like what I explained previously. So from this coordinate system, here we have the y coordinate. This is y, and this is x. So let's say each of these, let's say two square boxes represent 2 units. So let's say this is 2, this is 4, this is 6, this is 8, this is 10, and of course this is -2, -4, -6, -8. Then definitely this is -2, -4, -6. This is 2, 4, 6, and so on. Of course this is positive y, that's why you have positive numbers. This is negative y, this is positive x, this, and the origin is 0, 0. Okay, so now I said ordered pair gives the coordinate and location of a point. So the ordered pair of 2, 1, this 2, 1 is actually x, y, which implies that x is equal to 2 and y is equal to 1. So it is applicable to every other ordered pair we have. So let's look at it. So when x is 2, y is 1. So when x is 2, right, so if this is 0, if this is 2, definitely the first square box is 1. So when x is 2, y is 1. So this is excuse me, this one can be written as a, right, 2, 1. Okay, yes, 2, 1. Then the next one is, so this one is taken to be quadrant 1, quadrant 1. Okay, so when x is equal to -2, y is 2. So when x is equal to -2, y is 2. So this is b -2, 2. Then we also have c when x is equal, so we take this as quadrant 2, right? So this is quadrant 2. So for c, when x is -4, y is -4. When x is -4, y is -4. Okay, so when x is -4, y is -4, they intersect at this point. So this is C minus 4 comma minus what 4. So we'll call this quadrant 3. And lastly, when x is equal to 3, y is what minus 2. So when x is what 3, so x will be 3 here and y is minus 2. So this is D 3 comma minus what 2, which is what quadrant. This is quadrant 4. All right, so the whole thing I've shown here is what I call ordered pair. Basically, ordered pair gives the coordinates which we have here and the location. So the coordinate for A is what 2 comma 1, and it's located at quadrant 1. The coordinate of B is minus 2 comma 2, and it's located at quadrant 2. The same thing applies to C and D. So their coordinates is their what x comma y, and their what location is where they belong to in the quadrant system. So that is that about that. I want to believe this video has helped. So we move on to, let me change the background back to plain background. Okay, let me still leave it that way. Right, so let's now move on to relation and function. This is very important. A relation is a set of ordered pairs. It can be represented by a graph, right, a table, and mapping. And don't forget what I said previously about ordered pair, that it gives the coordinates and location. The key part of the ordered pair is the coordinate, because the location can actually change. What I call quadrant 1 2 3 4 here could be maybe A, B, C, D, or something else anyway. But the most important part of the ordered pair is the fact that you can locate it in the xy plane. So now the relation is a set of ordered pairs, and it can be represented by a graph, table, or mapping. So when we say being represented by a graph, it implies that a relation can actually be placed in a table. But the most important thing, it must have a domain which represents the x coordinate, and it must also have the range which represents the y coordinate. So the domain of a relation is a set of what all x coordinates from the ordered pairs, and the range is the set of all y coordinates which also represent the output of the what ordered pair. So let me give the different types of relation, how the relation can be represented. So for instance, what we had in the previous graph, we can actually put it on a table. How do I mean? If I put it on a table, that implies I'm going to be having x, I'm going to be having y. So what are the coordinates we considered? If you look at this, we considered what a 2 comma 1, b minus 2 comma 2, c minus 3 comma, and d. So a actually, right, gives us those coordinates, and b and c and d. So we can say the what, we can take a to represent, this will be the quadrant, right? Quadrant, excuse me, let me just use q there. So let's say this is the quadrant. So for quadrant, for quadrant A, or quadrant 1 as it were, we have A, which is what 2 comma 1. So when x is equal to what 2, y is equal to 1. Then for B, in this case we have B, we have minus 2 comma 2, minus 2 comma 2. So when x is equal to what minus 2, y is equal to 2. Then for C we have minus 4 comma minus 4, right? That implies that when x is minus 4, y is minus 4. Then D, right, we have 3 comma minus 2. When x is equal to 3, y is equal to minus 2. So what I'm having here is a relation, because it has been represented, right, in table. Now the same thing I have on table here, I can also have it as mapping. Don't forget that x represents the domain, that is all possible input, while y represents the range. Now what I have here, I can also put it in form of what mapping. Mapping is always like this. I just hope I'm gonna be able to draw it very well. So this is another mapping. So for this mapping, of course this is x, this is what y. So this is 2 minus 4 3. Then we have 1 2 minus 4 minus 2. So when x is 2, so this is what, one-to-one mapping, basically one-to-one mapping. Basically we have different types of mapping, so that is a bit advanced. So this is the concept of what, of relation. And finally, let's now look at a function. What is a function? A function is a special type of relation in which each element of the domain is paired with exactly one element in the range. This is a very important statement. Let me make it clear again so that when I begin to solve examples, you understand. A function is a type of relation in which each element of the domain, meaning that it is paired exactly with one element in the ring, meaning that each element here can only paired with one element in the what domain. You can't have two elements in the domain being paired with one element in the you can't have two elements in the range being paired with one element in the domain, but you can have two elements in the domain being paired with one range. So a function is a type of relation in which each element of the domain, that is the x, is paired with exactly one element in the range. So each of these elements cannot take 2 from y. If it takes 2 from y, it is no longer a function again. So we are going to be looking at examples whereby you'll be given a table or a mapping, and you are going to be making deductions to show if it represents a mapping or a function. So in the example, we are going to be saying that. Thank you for watching. I want to believe this video has helped someone. Looking forward to seeing you in the next video. Bye bye.